Hey there everyone, Ramesh here. Welcome back with another video. In this video, I'm gonna show you how to deploy Spring Boot MySQL CRUD REST API application on AWS using Elastic Beanstalk service. Alright, so I'm gonna show you how to deploy Spring Boot MySQL CRUD application on AWS using Elastic Beanstalk service. So we're gonna use Amazon Relational Database Service to set up our MySQL database on AWS Cloud. Okay, so Amazon Relational Database Service makes it easy to set up, operate and scale a relational database in the cloud. Alright, and here are the Amazon RDS database engines, and we're gonna focus on MySQL database. Okay, so we'll set up MySQL database on AWS Cloud using Amazon Relational Database Service. Okay, great. So look at here the workflow. So far we have created Spring Boot application and deployed on locally, and our Spring Boot application has connected with MySQL database, which is configured on local machine. Okay, now in this video what we're gonna do is we're gonna deploy our Spring Boot application on AWS Cloud, and we'll also deploy MySQL database on AWS Cloud using AWS RDS service, and we'll connect our Spring Boot application which is deployed on AWS with MySQL deployed on AWS Cloud. Okay, great. So let's take a look into the development process. First, we're gonna log into AWS console using AWS console credentials, and then we'll set up MySQL database in AWS Cloud using AWS RDS service, and then we'll connect our MySQL database that we have set up in AWS Cloud using RDS with MySQL Workbench to verify the connectivity. So once we set up MySQL database in AWS Cloud using AWS RDS, then we'll connect this MySQL database with our local MySQL Workbench just to verify the connectivity. And then what we're gonna do is we're gonna clone Spring Boot application source code from the GitHub repository, and then we'll update application.properties file just to change the database MySQL URL property. Okay, so we have set up MySQL database in AWS Cloud, right? And this AWS Cloud MySQL database URL we need to configure in application.properties file. Once we configure everything, then we package our Spring Boot application as a jar file, and then we'll deploy our Spring Boot jar file on AWS using Elastic Beanstalk service. Alright, once we complete Spring Boot application deployment on AWS Cloud, then we're gonna test the REST endpoints using Postman client. It's a pretty simple, guys, just we need to follow the steps. Okay, great. So look at here, this is a Spring Boot MySQL JP Hibernate RESTful CRUD API tutorial. So this tutorial I was published on my YouTube channel around 1 year back, and the source code of this tutorial we're gonna deploy on AWS. So basically you have two options. You can either create this project using this video tutorial, and second option is you can directly clone the source code of this tutorial from my GitHub repository. Okay, I have already hosted a source code of this tutorial on my GitHub repository. So in this video I am gonna clone the source code of this project from a GitHub repository, and will modify this project and will deploy on AWS. So if you are new to developing RESTful web services using Spring Boot, then I highly recommend you guys to check out this video tutorial. Okay, this is very popular tutorial on my YouTube channel, so go ahead and check out this tutorial to create CRUD RESTful web services with Spring Boot MySQL Hibernate. Okay, if you are already familiar with developing RESTful web services with Spring Boot, then you can directly go ahead and clone the source code from my GitHub repository. Alright, now let's go ahead and let's take a look into the steps, and let's go and let's implement the step one by one. So the first step is we need to log into AWS console. So we're gonna use AWS pre-developer account to deploy Spring Boot applications on AWS Cloud. So I have already created a couple of videos on deploying Spring Boot applications on AWS Cloud. So to understand the basics, you can go ahead and you can check out my previous AWS deployment videos. So let's head over to the browser and let's log into AWS console. In a new tab, just type awsamazon.com, hit enter, and this will bring you the home page of Amazon console. And if you haven't created an account, that is AWS free developer account yet, then you can go ahead and you can create an account. Okay, I have already created AWS free developer account, so I can go ahead and log into the AWS console. Alright, if you haven't created an AWS account yet, then you can go ahead and you can click on create new AWS account here. Alright, and this is a free tier product with a new developer account, so you can go ahead and provide all the details. And this is the first page. In a second step or second page, it will ask you to provide credit card details and other stuff. So you can go ahead and you can enter all the details, and you need to sign up to this AWS account. Alright, once you successfully sign up, then you can come back to sign in page and just enter your email ID. Just type the characters here in order to do the security check. Alright, and then enter the password. And there we go. So this is the Amazon management console page. Okay, now we have successfully logged into AWS management console. Now the second step is we need to set up MySQL database in AWS cloud using AWS RDS service. So let's go ahead and let's select AWS RDS service. So just scroll down and go to the database section here and just click on RDS. Alright, now what we're gonna do is we're gonna create a database. So let's go ahead and let's click on create database here. Alright, and choose standard create. So let's keep standard create as a default as it is, and here we're gonna choose MySQL database engine. Okay, so look at here the steps. We need to choose a database creation method and then engine option. Let's choose MySQL database here. Alright, and version keep default, that is 8.0.20 as it is. And look at here, this is important. Choose free tier. Okay, choose free tier, don't choose production. Okay, this will charge you, so you need to pay for this option. So just select free tier so that we can this is for just for learning purpose. You can go ahead and you can choose free tier here, and after that we need to create a DB instance. Well, let's go ahead and let's give instance name here. Just give Java guides. I will give Java guides, you can give any name that you want. And then here we need to provide a username and password for this DB instance. So I am giving the username as a root and password as a password, confirmation password. Alright, now let's keep this default DB instance class, that is db.t2.micro, and then storage keep everything default, and in connectivity just keep default these fields as it is. And here is the important field, that is public access. Say yes, Alright, and then go ahead and just click on additional configuration here. So let's keep this database port as it is because this is a default port for MySQL database server, and go ahead and click on additional configuration here, and here we need to provide the database name. Okay, so we can also create a database later on once we connect this MySQL database from our local MySQL workbench. Okay, so you have two options: either you can create a database directly from here, or you can create a database while connecting to this MySQL server from the MySQL workbench. Alright, and let's keep everything default. Okay, and say create database. Alright, if you look at the status here, so this is creating. Well, AWS will basically take several minutes to launch this DB instance, so let's wait a couple of minutes to bring this status as available, and then we can proceed accordingly. Alright, so this will take a couple of minutes to launch the MySQL DB instance. So meanwhile, what we're gonna do is we're gonna clone the source code of this project from my GitHub repository. Alright, go to the file system and just open a git bash here. So you can use a git to clone the GitHub repository, or you can simply go ahead and you can download this GitHub repository as a zip file here. Okay, I have already installed a git on my system, so I can use git to clone this GitHub repository. Alright, so just type the command git clone and just copy this URL and paste it here and just hit enter. Alright, we have successfully cloned this GitHub repository from GitHub. Alright, so if you can check out the application.properties file, just right click and edit with Notepad++, and look at here, we have configured MySQL local server URL here, localhost, and then followed by 3306 and name of the database, and this is username and password, and this is MySQL Hibernate Dilate. Okay, and this is a property to create tables automatically and update the tables automatically. Alright, now let's go back to the AWS console and let's see the status. It is backing up. Okay, let's wait a couple of more minutes to change this status to available, and there we go. The status is available and successfully created database Java guides. Okay, great. Now look at here, this is the DB identifier, so go ahead and click on this. Alright, and if you look at the connectivity and security section here, this is the endpoint URL, and this is the port, database port, and this is the security section, and this is the networking. Now what we're gonna do is we're gonna change the security up for this database. Okay, so go ahead and click on this default link here. So basically we need to provide a security to access this database from anywhere. So for that, let's go ahead and let's change the security here. Okay, just go ahead and click on this security group ID here. Alright, now just click on edit inbound rules. Now let's go and let's add a rule here. Just choose MySQL Aurora here, and then the source we need to change here, just change from custom to anywhere. So we need to access this database from anywhere, so let's choose anywhere here, and that's it, and click on save rules. Alright, so inbound security group rule is successfully applied. Now let's go back to our database instance. Alright, we have successfully configured MySQL database on Amazon AWS cloud using RDS service. So next step is we need to connect MySQL database with MySQL Workbench to verify the connectivity. Let's head over to the MySQL Workbench and let's make a connection from MySQL Workbench to this MySQL database that we have just configured in AWS cloud using AWS RDS service. So go to the MySQL Workbench like this, and so look at here MySQL connections. So this is a plus icon. Go ahead and click on this plus icon here, and this will bring you the pop-up screen, and here we need to just enter the details. Connection name, just provide Java guides, Java guides on AWS, something like this. And here host name, so let's give a host name as endpoint URL. So let me show you how to get the host name from the AWS cloud. So look at here, this is the Java guides DB instance, right? And if you go to the connectivity and security section, here we have endpoint and port. So you need to copy this endpoint. So this is the endpoint or host for this database. Just copy and paste in a host name section, and we have provided username for database as a root and password as a password, and just click on test connection. Here we go, successfully made the MySQL connection. That's awesome, right? We have successfully made a connection from MySQL Workbench to MySQL database on AWS cloud. Alright, click on OK and click on OK here also, and here we go. So go ahead and click on this connection here. Alright, we have successfully made a connection from MySQL Workbench to MySQL database on AWS cloud. Let's take a look into the next step. So next step is we need to clone Spring Boot application source code from GitHub. So we have already completed this step. So next step is we need to update application.properties file to just change the JDBC MySQL URL property. Alright, we have configured MySQL database on AWS cloud using AWS RDS, right? Now we're gonna simply replace a localhost MySQL database URL with a MySQL database which is configured on AWS cloud. So just go ahead and copy this endpoint or host name and go to the application.properties file of our Spring Boot application. So look at here, this is the JDBC URL, right? JDBC MySQL URL, and earlier it was pointing to localhost MySQL database. Now let's go ahead and let's replace from localhost to this host name. Okay, so this is the MySQL database URL which was hosted on AWS cloud. Alright, that's it. Now let's go ahead and let's create users DB database inside MySQL database. So let's go ahead and let's head over to the MySQL Workbench, and here just write the query create database followed by name of the database, and execute the query here, and just go ahead and refresh the schemas, and there we go, we have successfully created users DB. Okay, and this database is created on Amazon cloud because we have successfully made a connection to MySQL DB instance on Amazon cloud, right? Now we have created users DB database. Let's take a look into the next step. Alright, so next step is we need to package our Spring Boot application as a jar file, and then we'll deploy this Spring Boot jar file on AWS using Elastic Beanstalk service. So go back to the application.properties file again, and what we're going to do is we're going to change the Spring Boot application server port. So by default Spring Boot application a port 8080, right? That is embedded Tomcat server port. But Elastic Beanstalk service expect Spring Boot application to listen a port 5000. So let's go ahead and let's just change the port number here, server dot port. So this is the property to change the default port. So let's go ahead and let's give port number as 5000. Okay, now go to the file system, and we need to package our Spring Boot application as a jar file. So let's click here and just type cmd. So this will bring a cmd inside this folder, and just go ahead and just type Maven. So make sure that you have installed Maven on your machine. Just type Maven clean install and hit enter. So this will make a Maven build for this Spring Boot application. Let's wait a couple of seconds. So look at here, the build is failed because we have provided a wrong database password. So let's go back to application.properties file, and look at here, we haven't changed the password here. So we have provided username as a root and password as a password, right? So this is important, guys. So whenever you configure MySQL database on Amazon cloud, you need to replace the host here and then username and password. Okay, now let's go back to the command prompt, and here let's again enter the command maven clean install. Alright, the Maven build is success, and go to the MySQL workbench and just refresh the schemas here, and look at here, the users table is also created. Okay, now go to the file system again and go to the target folder, and this is the Spring Boot jar file. Now what we're gonna do is we're gonna deploy this Spring Boot application jar file in AWS cloud using Elastic Beanstalk service. So we have successfully packaged Spring Boot application as a jar file. Now we're going to deploy this Spring Boot jar file on AWS using Elastic Beanstalk service. So let's head over to again Amazon website and go to the services, and in a compute section click on Elastic Beanstalk. So if you are new to Elastic Beanstalk service, then you can watch my previous AWS deployment videos where I have shown you step by step how the Elastic Beanstalk service works and how to deploy step by step Spring Boot application on Elastic Beanstalk service. Alright, now go ahead and click on create application button here, and here we're going to provide application name, for example Spring Boot MySQL and MySQL CRUD AWS. Okay, something like this. And after that you can also provide application tags here to just group and filter your resources. And here in a platform section just choose a Java. So because we have packaged our Spring Boot application as jar file, right, and we're gonna run our jar file using Java command. So for that we're gonna choose a Java here and keep platform branch as it is, and platform version keep this recommended one, and just go ahead and click on upload your code here and keep version label as it is. So this is the default name provided by AWS, and click on choose file. Alright, and just go to the folder where your jar file is created, go to the project, go to target folder, and here we go. So this is the Spring Boot jar file, so select it and hit open, and this will upload this Spring Boot jar file in S3 server. Okay, basically Elastic Beanstalk service, it will provide all the resources that we require to deploy our Spring Boot application. So behind the scene, it will create a EC2 instance for us. It will create S3 server and it will upload this jar file in a S3 server. Okay. All right, and go ahead and click on configure more options here. And go to the database section here and click on edit. And here we need to provide a username and password. So we have provided username as a root and password as password. And that's it. Click on save. And go ahead and click on create app. So basically Elastic Beanstalk service will create an environment to deploy this Spring Boot application. So look at here, Elastic Beanstalk service first create EC2 instance, and then it will create Amazon S3 server storage bucket for storing our Spring Boot jar file in it. Let's wait a couple of minutes. It will take a couple of minutes to create this environment. Alright, so look at here, our application successfully deployed and health is okay. Now let's go ahead and let's click on this link here. And there we go. Our Spring Boot application successfully deployed. And just type here API/users to list out all the users. So we haven't created any user in a database, so that's why this REST point returns IMT array. Now we have successfully deployed our Spring Boot application on AWS Cloud. Now what we're gonna do is we're gonna test CRUD REST APIs using Postman client. So let's head over to the Postman client and let's test all CRUD REST APIs. So if you go to the Spring Boot project on GitHub, that is Spring Boot CRUD RESTful Web Services project, just go to the main, go to the controller here, and this is the user controller class, and look at here, this user controller class exposes CRUD REST APIs like get all users, get user by ID, create user, update user, and delete user. So we're gonna test all these REST APIs, and this is the REST point base URL for these REST APIs. Okay, great. So let's head over to the Postman client. And before that, let me just copy this URL, and in a Postman client create a new request, and here just choose a get HTTP method here, and just enter the URL just we have copied from the browser, and hit send button, and here we go. Okay, nothing is there in a database. Now what we're gonna do is we're gonna insert few records. For that, let's choose HTTP post method here, and go to the body and go to the raw and choose content type as JSON here, and just create a JSON object quickly here. So look at here, our entity has fields first name, last name, and email. Okay, just give first name here, let's say Ramesh, and last name Padatare, and then email ramesh@gmail.com. Alright, now let's go ahead and let's click on send button, and there we go. We have successfully inserted a record in a database, and REST API return this response. Now let's head over to the MySQL workbench and let's verify this record in a database. So just go to the users database, that is users DB, and this is the users table. Right click on it and say select rows, and there we go. A user is inserted in a database. Okay, now let's test other REST APIs. So let's go and let's test get user by ID REST API. So we just pass the id 1 here to get this user by id 1 and hit send button, and here we go, we got user 1 in a response. Okay, now what we're gonna do is we're gonna update this user. So just choose HTTP method put here and change post name from Ramesh to Ram, and change email as well. Okay, and hit the send button here, and there we go, post name and email successfully updated. So look at here the response. Okay, and if you check the database, just execute this query, select query, and you can able to see here the email and post name is updated. Now let's go ahead and let's test delete user HTTPI. Click on delete HTTP method and hit send button, and there we go. Okay, so we have successfully deleted a user, and this REST API returned 200 okay as a response code. Now let's verify in a database. Let's go ahead and let's execute this statement, and there we go, the record is deleted from the database. Alright guys, we have successfully deployed our Spring Boot MySQL REST API code application on AWS Cloud, and we have tested all the REST endpoint URLs using Postman client. Now let's recap the steps what we have done. We have logged into AWS management console, and we have set up MySQL database in AWS Cloud using AWS RDS, and then we have connected this MySQL database which we have set up on AWS Cloud using MySQL Workbench to verify the connectivity, and then we have cloned the Spring Boot application source code from GitHub repo, and then we have updated application.properties just to change JDBC MySQL URL from localhost to MySQL database which was deployed on AWS Cloud, and then we have packaged our Spring Boot application as jar file, and then we have deployed our Spring Boot jar file application on AWS using Elastic Beanstalk service, and we have tested all the REST endpoint URLs using Postman client. Alright guys, pretty simple, just follow the steps. Okay, and yeah, so if you found this video useful, then subscribe to my YouTube channel, and yeah, I will see you in the next video with another interesting concept. I will see you in the next video.